Abundant Grace International School, we are located right in Obuasi, precisely BDM. The school has a number of facilities that aid in learning. We have qualified and trained teachers who are ready and willing to assist the children. The school has many facilities such as the ICT laboratory. We also have a science laboratory. We also have a library. The school has a number of buses which convey the children from their various destinations to the school premises. We have the football team, we have the drama group, we have a lot, and the school is based on the Christian principles. For more inquiries, you can call this number 0541 310 901 0541 670772. Abundant Grace, in God we trust.
You're welcome back to the science session. On Monday, we started treating acid and bases. Now we started with the properties. Now we define the term acid. And also we move on to the properties. Now the properties are very important. I want you to pay attention. The properties is very important. They normally ask questions concerning the properties. They normally ask questions concerning what the properties. So I want you to pay extra attention to what I'm going to say. So if you are going to answer any question concerning acid and base, the questions are always based on the properties. So I want you to pay attention. So on Monday, we reach the fourth property. Which is acid react with metals to produce hydrogen gas. For example, the example is on your screen. You can see it. You can see the example. So the first one, we have zinc. Now zinc is the metal and HCl is the acid. So this is the metal. So this is the metal and this is the acid. If they react, you get hydrogen gas. You get salt and hydrogen gas. So this one is positive and negative. So this, we take this. So you write the name of the metal first. Then you write your hydrogen gas. So this one appears in the chemical reaction as diatomic molecule. And because of these two, it has changed the whole thing. We have two atoms of hydrogen here. Here too we have one. And because of these two, it is affecting the H. So you have to write 2 in front of the hydrogen. So this 2 is multiplying H and Cl. And because of that, you have to write 2 here. So the equation is balanced. So the four properties, acid react with metal to produce salt and hydrogen gas. So this is the salt. And we have the hydrogen gas here. So this one is very simple. So today, we are moving to the fifth property. Let's move to the fifth property. The fifth property says that strong acid conduct electricity effectively in aqueous solution. Strong acid also conducts electricity in aqueous solution. Take note of that. Acid can also conduct electricity in an aqueous solution. Now, here, the C's property is very important, and we are going to do some balance of chemical equation here, so I want you to pay attention. Now, they react with bases to produce salt and water. They react with bases to produce salt and water. Now, we have it on your screen. CHCl plus NaOH. Now, this is the acid, and sodium hydroxide is the base. So acid reacts with base to produce salt and water. Now let us do simple balance of chemical equation. So we have the H here, we have the chlorine here. So this one is positive, negative, positive, and OH. They are together. So here we have NaCl plus. So we have NaCl plus water. So this one is the salt. Sodium chloride is the salt, and this is water. So acid reacts with base to produce salt and water. This one is simple. You have to know that, you have to put it in your head that acid, anytime acid reacts with base, you get salt and water. Let me give you a typical example. In the stomach of human being, we have this acid in the stomach of human being, hydrochloric acid. So if you're having stomach ache or your stomach is paining you, as soon as you go to the hospital, the doctor will give you medicine that contains base. So as soon as we take in that medicine, it will balance the acidic content in the stomach, which will help the person to recover from that stomach ache. So take note of that. So this one, we have hydrochloric acid in the stomach of human being. So any acid, any medicine that is used to treat stomach ache or any stomach medicine contains a base, which help the doctors to balance, which help the doctors to make sure that the acidic content in the stomach are balanced. So take note of that. Now, let's go to another example concerning this reaction. We have H2SO4. This is known as sulfuric acid. This is known as sulfuric acid. Now, this acid can also react with base to produce salt and water. To produce salt and water. The same thing. So this one too is not difficult. So take note of that. So I hope you can write any base. You can write any base here to produce what? Salt and water. Salt and water. So we have here too, you can write your sodium hydroxide here. This is the base. This is the base. So we have SO4. All these are 1. SO4. So this, we take this. This one is negative. This one is cation, and this one is the anion, and this one is the cation. So you write the name of the anion first, the cation first, which is sodium, then SO4 plus H2O. Now, this is the acid, and this is the base. So here, sodium sulfate is the salt. And we already know that H2O is water. So acid reacts with base to produce salt and water. And this reaction is known as neutralization reaction. They normally ask this question. This reaction is known as neutralization reaction. Now, so you can see the first example. The first example is hydrochloric acid and sodium hydroxide. You get sodium chloride, which is known as common salt. This is the salt, and we have the water here. So these are the products. These are the products. And this is known as reactant. In chemical equation, this is known as the reactants and products. So you have to put it in mind that anytime acid reacts with base, the first product that is produced is salt, and the second product is water. Now look at the first example here. So we have ACl plus sodium hydroxide, which is base. Here you get sodium chloride plus water, and these are the products. The next one is what? Sulfuric acid. The next example is sulfuric acid, H2SO4. Sulfuric acid. This is a common name for this compound, sulfuric acid. Sulfuric acid also combined with what? Sodium hydroxide. You get sodium sulfate plus water. So the sodium sulfate is the salt, and water is and the next product is what? Water. H2O is the water. We all know the chemical formula for water. Now, without wasting my time, let's go to base. Let us define base. Let's define base. Now, the definition of a base is the opposite of the definition of an acid. So if you know how to define base, if you know how to define an acid, then automatically you have to define base. So in our previous lesson, we define acid as what? It's a compound that turns blue litmus paper red. So if you are told to define base, is the opposite of acid. So you have to define the term base. So a base is a compound that turns red litmus paper blue. A base is a compound that turns red litmus paper blue. So this one too is simple. So if you are told to define base, I hope you can get the definition of a base from the definition of an acid. Because an acid is a compound that turns blue litmus paper red. Here, a base is a compound that turns red litmus paper blue. This one is simple. Or a base is a compound that produces hydroxide ion. That produces hydroxide ion when dissolved in water. When dissolved in water, I'm talking about this ion, hydroxide ion. This one is also known as hydroxyl. Hydroxide ion when dissolved in water. When dissolved in water. So all the base, either it will end with this or this atom. So we have, for example, we have sodium hydroxide. For example, we have sodium hydroxide. This is a typical example of what? A base. It will produce, when dissolved in water, if you put this compound in water, it will produce this ion. So we have, if you put it in water, you can get this. We have water here. Here you get sodium, ion, and hydroxide ion, like this. You can get it, if you put this compound in water, you get this ionic formation. So a base is a compound that produces hydroxide ion when dissolved in water. So I'm talking about this. This one is very important. So this one is a typical example of what? A base. We also have potassium. This one too is a base. Calcium oxide too is a base. So all these are typical examples of what? A base. So a base is a substance that turns red litmus paper blue. Or a base is a compound that produces hydroxide ion when dissolved in water. When dissolved in water. So this one is so simple. Now let's go to some examples of base. I've already written some on the board for you. You see. Now, examples of base. We have sodium hydroxide. This one is a base. Calcium oxide is a base. But sodium hydroxide. Potassium hydroxide is also a base. We have this one. There. It's also a base. Calcium hydroxide. We also have calcium hydroxide. Calcium hydroxide. Now, we don't write calcium hydroxide as CaOH. If you write this one, you are wrong. This one is different from this. This one is different from this. I'm going to talk about that. Now, I want you to pay attention. Now, look at the first formula. Ca into bracket OH to bracket close 2 here. This 2 is multiplying the H and the O. If you write this one, you are wrong. I want you to pay attention. Now, look at the valency of calcium. Here, this calcium is having a charge of 2. This calcium is having a charge of 2. And this one, OH, is having a charge of 1, negative 1. So the valency of this calcium is 2, and the valency of this hydroxide ion is 1. Because of what? Their charges. We deduce a valency from the charge of the atom. So this one is simple. So if you want to write a chemical formula, now these 2 will go here, and this one will come here. So these 2, instead of writing it here, you write the 2 here, and the 1 here, you write it here. So you just, I would clean this one. So when you combine them together, you get C. When you combine them together, you get Ca into bracket OH2. Here we don't write the 1. Now the 1 belongs to this calcium and the 2 belong to this H. That is why it is written in this form. That is why it is written in this form. So I want you to understand this. We don't write calcium hydroxide like this. If you write this one is wrong. Now the reason why we write sodium hydroxide as this, now let's go to this formula. Sodium hydroxide, NaOH. Why not like this form? Now, the valency of sodium, the charge of sodium is what? Plus, Na plus, which means it is having a charge of what? 1. This one too, we have OH, a charge of negative 1. So this, you write your 1 here, you write your 1 here. So here is 1, here is 1. So we don't write it in the form of what? Any bracket. So we have sodium hydroxide because this one is having a valency of 1. This one too is having a valency of 1. So if you combine them, you just write NaOH. But here, the calcium here is having a valency of 2. And this OH is having a valency of 1. So if you cross them, then you get Ca into bracket OH2. This is how you write sodium hydroxide. Sodium hydroxide. I want you to take note. Now, another example. Is calcium hydroxide, sorry. So another example, we have magnesium hydroxide. Magnesium hydroxide is also written in this form. You cannot write you can't write Mg. This one too is not accepted. This one too is not accepted. So you cannot write MgOH. This one is wrong. The same procedure. The magnesium is having a valency or a charge of 2. So automatically the valency of magnesium will be 2. So if you write the ionic formation, you get this one here. So if you cross automatically, the valence of this will be, the 2 will come here and the 1 will be here. So this one will give you, this 2 belongs to this. So you just write your Mg 2 bracket OH2. OH2. So this is how it is written. This is how it is written. So all these are examples of base. All these are examples of bases. So magnesium hydroxide, sodium hydroxide, and so on. Calcium oxide. All these are examples of base. So I want you to take note of them. So if you are writing the chemical formula, they can write down the words. They can ask you to write down the chemical formulas. Now, for example, so we have some examples on the board. Write down the chemical formula of the following compounds. Now, they can give you in this form. So you have to write down their chemical formulas. So that is why I gave you numerous examples for you to understand. Because magnesium hydroxide, look at this one. Magnesium hydroxide, if you don't know how to write the formula, you write it in this form. MgOH, you are wrong. Before you write down any chemical formula, you have to know their valences before you write down any chemical formula. This one is very important. I want you to take note of that. Before you write down any chemical formula, you have to know their valences before you write down any chemical formula. Now, look at the first one. Magnesium hydroxide. Somebody will write this one. If you write down this formula, it means that you don't know the valences of the various ions. Now, the valence you don't know the valences of the following element or ion. Now, look at this one, magnesium. This one is having a charge of 2. This one is having a charge of 2. OH is having a charge of -1. But we don't write a charge of -1, but we don't write. Here, magnesium is having a charge of +2. So its valency is 2. And here, OH, hydroxyl, this one is having a charge of -1. Its valency is 1. I want you to take note of this. Now, before you write down the chemical formula, you do what? You're crossing like this. So these 2 will come here, and this one will come here. So this one belongs to this, and this 2 belongs to the OH. I hope you can see it on the board. So when you are writing the chemical formula, this one belongs to this, and this 2 belongs to this. But we have OH here. So it means that the 2 is affecting the oxygen and the hydrogen. It means that the 2 is affecting the oxygen and the hydrogen. So you write it in this form: M Mg into brackets OH2. This one is very simple. I hope you understand what I'm saying. This one is very simple. This one is very simple. So this one, you write the formula. MgOH. Calcium hydroxide. Calcium hydroxide is the same, you follow the same procedure. You follow the same procedure. C. So you write your 2 here, you write your 1 here. So this one will give you Ca to bracket OH2. So you just write your formula. Then sodium hydroxide. We have sodium here, OH here. Sodium hydroxide, we have this is having a valency of 1. This one too is 1 based on their charges. So here 1, 1. So you divide both sides by 1, then you get the same thing. So then you write your NaOH. NaOH. So this one is simple. Then OH. And the next one is carbon dioxide. We all know that carbon dioxide is CO2 because it is having 2 atoms of oxygen. The term di means 2. Di. In sign, di means 2. Tri means 3. Tri means 3. Tetra means 4. And so on. Tetra means 4. So di. And mono means 1. Mono means 1. So this one, let me give you a typical example. Now, CO. We have CO. This CO is known as carbon monoxide. This CO is known as carbon monoxide because it's having only 1 oxygen atom. It is having only 1 oxygen atom. Now we are done with the examples of bases. Let's go to types of base. Let's go to types of base. We are done with some examples of bases. We have for the first one is potassium hydroxide, sodium hydroxide, calcium hydroxide, and magnesium hydroxide. It is on your screen, you can see it. Now, let's go to types of base. We have 2 main types of base. We have 2 main types of bases. These are organic and inorganic base, as in acid. We have organic acid and inorganic acid. Now here, organic acid organic bases occur in nature, as in acid. The same thing applies what? Inorganic base. Inorganic base are manufactured in the science laboratory. Inorganic bases are manufactured in the science laboratory, and organic bases occur in nature. Put that in mind. Just that's the definition. If you are told to define it, you can use this to define organic and inorganic base. Now let's talk about organic base. These are bases that occur naturally in plants, animals, and other living things. For example, we have saltpeter. I guess you know saltpeter, the ladies, aka ekam. This one is used to what? Prepare food. This one for tomato. Typical stew is what? Tomato stew. Tomato contains a lot of acid. So if you put the saltpeter in, or if you put the ekam in that stew, it will balance the acidic content in that stew. So that if you take in or if you consume that stew, you will not get a stomach ache. Because already we have hydrochloric acid in the stomach. So it is very important. Tomato contains high amount of acid, organic acid, but they are less harmful to man. All organic acid are less harmful to man. So typical examples are saltpeter, wood ash, cocoa peels, and wasp stings. So, for example, cocoa peels and wood ash are used in what? Soap production. Local soap like what? Amonchin. We all know that amonchin. Amonchin, that is black in nature. So, we normally use bases in what? Soap industries. Soap industries. So, these are examples of what? Organic bases. Example, we have saltpeter. Saltpeter is used in food preservation. Saltpeter is used in food preservation. It is known as a keon in local language. It's known as a keon. So if the stew or if the food you are preparing contains a lot of acid, you have to add this small amount of saltpeter so that it will balance the acidic content in the food. Now this one we have now typical example is what? Milk of magnesia. This milk of magnesia is an inorganic acid. It is always prepared in a science laboratory. This one is used in the hospitals. They use it for the treatment of stomach ache and so on. We have another example known as Buscopan. Buscopan too is also a form of base, but this one is also prepared in the science laboratory. This one too is used in the hospital for treatment. So we are done with organic base. I hope if you are told to state 2 examples of organic base, you can write down something. We have saltpeter, wood ash, cocoa peels, and wasp stings. So these are organic base. They occur in nature. And the sources of organic base are animals, plants, and other living things. Now, let's go to inorganic base. Inorganic base are also manufactured in science laboratory. You can see some in the examples over there. We have potassium hydroxide is example of inorganic base, sodium hydroxide, calcium hydroxide, magnesium hydroxide. All these are typical examples of inorganic base. These are manufactured in science laboratory. All these are manufactured in science laboratory. So this is typical example of inorganic base. Now, without wasting my time, let us go to the properties of base. Now, one of the properties of an acid, I told you that acid is having a sour taste. An acid is having a sour taste, which means that it's neither sweet nor bitter. But here, in the properties of base, the first property is opposite of the properties of acid. If an acid is having a sour taste, then the base is also having a bitter taste. A base is also having a bitter taste. Now, you can see the property on your screen, the second property. They are bitter in taste. If something is bitter, it means that they're bitter in state. Now, the first one, bases change the color of litmus paper red to blue. So, if an unknown solution is in a certain bottle, and if you want to check whether the solution is acidic or base, now you first take your red litmus paper. You just dip in the red litmus paper. If the red turns to blue, it means that solution is acidic. That solution is acidic. Now, 2, they are bitter in taste. I've said it. Now, the third one, bases lose their basicity when mixed with acid. They lose their basicity when mixed with acid. It means that they lose their basic properties when mixed with acid. This one is very simple. The next one, bases react with acid to form salt and water. Bases react with acid to form salt and water. Now, let's go to the board. Base plus acid amounts to salt and water. So if base reacts with acid, automatically we will get salt and water. We will get salt and water. So I want you to pay attention to this property. Now, for example, if you take sodium hydroxide plus hydrochloric acid, you can see it on the board. Now, this will take the chlorine, sodium, so write the name of the metal first. Don't forget to write the name of the metal first. So here we have sodium chloride. So this is the salt. We have H2O. So here, let us talk about what the reactant. So here is the reactant. And products. So anytime base reacts with acid, the products are salt and water. So here, this is our base. Then this is our acid. Here too, this is our salt and the water. So these are the reactants and these are the products. So anytime a base reacts with acid, you get salt and water. You get salt and water. This one is not difficult. This one is not difficult. You get salt and water. So we have sodium hydroxide. I told you that a base is a substance that produces hydroxide ion when dissolved in water. So this is hydroxide ion. So if you separate them, you have let us write down the ion formation. This one is cation, and OH is anion. So these are their ion formation. They come together to form this compound. So if you combine this, then you get sodium hydroxide. Sodium hydroxide. The same thing applies to this. We have H being positive here, and we have Cl negative. So they combine to form hydrochloric acid. So if you are told to write the balance of chemical equation, the positive will take the negative here. So here, after that, you get your salt, sodium chloride. What is the salt? Sodium chloride. What is the? So here we have one atom of oxygen here. We have one atom of hydrogen, and that atom of hydrogen here. So when they combine, we get two atoms of hydrogen and one atom of what? Oxygen. So if you know the chemical formula for water, you just write down the chemical formula, because water is formed when two atoms of hydrogen combine with one atom of oxygen. So this is the chemical formula for water. This is the chemical formula for water. Now, another important property, and I want you to take note of that. Another important property. Now we have a base. This one, a base reacts with what? Acid to produce salt and water. This one is known as, this kind of reaction is known as neutralization reaction. They normally ask this question. So this property is very important take note of this property. This one can be found in acid, and this property too is found in base. So it is very important. I want you to take note of that. It is very important. So they normally ask questions concerning this. They normally ask questions concerning this property. So if you don't know how to balance your chemical equation, learn how to balance your chemical equation. It is very important. Now let's go to another property of a base. Another property of a base. Now, some bases are great conductors of electricity. Now, before I do the explanation, let us draw our pH scale. Some bases are good conductors of electricity. Some acids are also good conductors of electricity. Take note of that. For example, we have potassium hydroxide conducts electricity. Now, before we proceed, let us draw our pH scale. It's ranging from 1 to 14. It ranges from 1 to 14. So the middle part here is 7. Here is 7. So this is neutral. It's 7. So here we have 0 here, 2, 14. 14. This is the pH scale. This is the pH scale. 14. Now, from 0 to 3, this range of pH are very strong or concentrated acid. Thanks. So this one from 0 to 3. In some books they range from 0 to 2. Very hard. If you test an acid and that acid is having a pH of from 0 to 2, it means that acid is highly corrosive or highly concentrated. Highly concentrated. So you can see this arrow from here and here to it goes this way. So here is increasing in acidity. Now here to you just write your increasing in basicity. This one is very simple. So if look at the arrow. If an acid is having a pH of 0, 1, 2, it means that acid is very strong acid. It means that acid is very strong acid. Now, weak acid ranges from 4 to 6. Weak acid also ranges from 4 to 6. So you can see the direction of the arrow, increasing in acidity. So if it goes this way, it means that if it ranges between 0, 1, 2, and 3, it means that solution is a strong acid. That solution is a strong acid, very concentrated acid. Now, the next one, let's go to the base. So 7 is neutral. 7 is neutral. Typical example is water. Water is having a pH of 7, which means that water is neutral. Water is neutral to litmus paper. Water is neutral to litmus paper. It means that if you put litmus paper, red litmus paper in water, the color will remain the same. The same time, if you put blue litmus paper in water, its color will remain the same. There's no change in color. I want you to take note of that. This one is very simple, so I want you to take note of that. So the 7 is neutral. The 7 is neutral. Now, look at this. Oh, this one, it goes this way, increasing in what? Basicity. So if a solution is having a pH of 14, it means that that base is very corrosive or very concentrated. Now, look at 12, a pH of 12, pH of 13. All these are strong base. All these are strong. If a solution is having a pH of 13, pH of 12, pH of 14, all these can conduct electricity. They are strong base, highly concentrated. They can burn the skin if they pour it on you. They can burn your tissue. Now, let's talk about the weak bases. From 8, 9, and 10. All these are not strong. All these are not highly corrosive. They are not corrosive. They are what? Known as what? Weak base. Up to 11. They are all known as what? Weak base. But from 12 to 14, they are very strong or corrosive. This is the pH scale. This is the pH scale. So they can draw it for you to indicate whether they can draw this pH scale for you to indicate whether a solution is a strong or weak base or a strong or weak acid. So we have to take note of that. It is based on their pH scale. So if a solution is having a pH of 0, pH of maybe 14, pH of 6, state whether the solution is strong acid or base, or weak acid or base. So you have to know. So if a solution is having a pH of 0, it means that that solution is strong acid. If the solution is having a pH of 14, it means that that solution is what? Strong base. If the solution is having pH of 6, it means that that solution is weak acid. You have to know all these things. They can trick you because understanding the question is part of the examination. So they can put the question in any form. So you have to be prepared to answer any question concerning acid and base. So you have to be prepared. Now, let's go to another property of base. Some of the base can conduct electricity. We have potassium hydroxide is having a high amount of pH. The pH number ranges from 13 to 14. We have used as what? Electrolyte. If something is electrolyte, it means that that substance can conduct electricity. If something is electrolyte, it means that that substance can conduct electricity. Now, 7, we have alkalis are bases that produce hydroxyl ions. So I told you earlier on. So this one is known as hydroxyl. Hydroxyl ions. Hydroxyl ion, when mixed with water. I have demonstrated it on the board for you to see. When mixed with water, it always produces what? This ion, hydroxyl ion. Now, strong alkalis are highly corrosive in nature. If something is highly corrosive, it means that that substance can bend the skin. That is why they normally pour acid or strong base on somebody to deform the person. They can even use it to kill somebody. If somebody wants to deform you, as soon as the person pour acid on you, it will deform you for the rest of your life. So you have to be very careful in life. It is not all that expensive. That person can go to the market and buy it It is not costly. If you get 10 cedis, you can get an asset to buy, or 15 cedis or 20 cedis, you can get an asset to buy. So that is why people normally use this one to deform people. So alkalis, strong alkalis are highly corrosive in nature. They are highly corrosive in nature, whereas other alkalis are mainly corrosive. Okay, whether these are other alkalis. Okay. Mainly what? Corrosive in nature. It means that it is not all that strong. It is not all that strong. It is not all that strong. Now, the pH value of bases ranges from 8 to 14. From 8 to what? 14. It is on the board. From 8 to 14. The pH value of bases ranges from what? 8 to 14. And the pH value of acid ranges from 0 to 6. Take note of that. The pH value of bases ranges from 8 to 14. And the pH value of acid ranges from 0 to 6. So 7 is neutral. 7 is neutral. And substance that has a pH of 7 is water. Typical example is water. Water is neutral to litmus paper. Water is neutral to litmus paper. Now we shall meet on Friday. Friday we are going to continue with acid and bases. Friday we are going to continue with acid and bases. So I want you to watch this channel on Friday. Friday too, we are going to solve some questions concerning acid and base. See you on Friday. Thank you for watching ATPS TV.
Abundant Grace International School, we are located right in Obuasi, precisely BDM. The school has a number of facilities that aid in learning. We have qualified and trained teachers who are ready and willing to assist the children. The school has many facilities such as the ICT laboratory. We also have a science laboratory. We also have a library. The school has a number of buses which convey the children from their various destinations to the school premises. We have the football team, we have the drama group, we have a lot, and the school is based on the Christian principles. For more inquiries, you can call this number 0541 310 901 0541 670772. Abundant Grace, in God we trust.